हरि करना।
So now let's look into the one of the very important testing, that's ANOVA. So before we look into the ANOVA, that analysis of variance test, so what will we do is we will look into the various types of data, and for the various levels of measurement, what kind of statistical test we can use. So that we will see here. If we will mainly focus on dependent variable first. If your dependent variable is interval ratio, either interval or ratio or dichotomous, you can go for the independent samples t-test. And if your dependent variable is nominal or dichotomous, you can use crosstabs. If your dependent variable either interval or ratio or dichotomous, and independent variable is nominal or dichotomous, is in any these cases you can use ANOVA. And finally, if your dependent variable is completely numeric, interval or ratio, then you can go for the correlation and regression. So anyway, now we will be looking into the ANOVA, analysis of variance, very important when it comes to the data science as well as statistical analysis. So first, let's look into the basic ANOVA situation. So where we can use it. One, two variables you have. One is one categorical, other one is quantitative. And two, so main question it answers is, do the means of quantitative variables depend on which group the individual is in? And so if categorical variable has only two values, it's fine. You can do it with the two sample t-test. If it has only, if that categorical variable has only two values, you can do with the two sample t-test. But by no but if it has more than three or more groups, then you have to go for the analysis of variance. So ANOVA, the name itself says analysis of variance. This completely works on analyzing the variance, breaking the variance into two components. What is that, we will see later. So just like because of some excitement I told you, and I'm trying to explain ANOVA now only. Okay, no, but let's go step by step. So if any categorical variable has three or more groups in it, then we will use ANOVA. This is clear for now. Now let's move ahead. So let's take one example situation for ANOVA so that you can understand ANOVA better, much better. Okay, so let's take 25 patients. All these patients that you can see have a blisters. So these are the 25 patients with blisters, and I have three treatments. One is treatment A, treatment B, and then placebo. So now, so I want to measure number of days until blisters heal. So with the treatment A, how many days it will take the blisters to heal, and with the treatment B, how many days it will take the blisters to heal, and then final one. So now I have collected the data for the treatment A. For one guy it took 5, then second guy 6 days, 6 days, 7 days, 7 days, 8 days, 9 days, 10 days. And using treatment B, 7, 7, 8, 9, 9, 10, 10, 11. For the with the last one P, 7, 9, 9, 10, 10, 10, 11, 11, 12, 13. So I've taken the mean for treatment A and treatment B and the treatment P. So the mean number of days until the blisters healed was 7.25, and the mean number of days until blisters heal using the treatment B is 8.875, and then mean number of days until blisters healed with the P is 10.11. Now the question comes, so this is what the observed data, this is what the observed records or observed mean. In a simplest way, these are all observed mean. Now the question, are these differences significant? That's what the question. Are these differences significant? A null hypothesis, always null hypothesis says these are all same. Null hypothesis says these are all same. Whereas alternate hypothesis says these are not same. So based on taking these alternate hypothesis and then null hypothesis, we will move ahead. So this is clear now. So this is what, when you have three groups, such more than two groups. Now if you want to find the difference, whether it is significant or not, if you want to do the significance test for groups more than two, then you have to take up ANOVA. That's what I want to prove from here, nothing else. So now, assumptions of ANOVA. Each group is approximately normal, and check this by looking at the histograms and our normal quantile plots, or use some assumptions. Can handle some non-normality but not severe outliers. And then standard deviations of each group are approximately equal. So rule of thumb, ratio of largest to smallest sample standard deviation must be less than 2:1. If that's matching, so if these assumptions are fitting well, then ANOVA can give you the proper result. So let's look into the notion. Let's look into the notation for ANOVA. So N means number of individuals altogether, and I is equals to number of groups. X bar, capital X bar, is mean of the entire data set. Entire data set. And then group I. Now it's specific to the, these are all specific to the overall data set, whereas these are specific to the groups. Ni means number of individuals in that group only. So Ni. Ni is number of individuals in that group. Xij, so xji, value for individual j in group I. And xi mean, this is a mean for group I. X bar is mean for entire data set. X bar I is mean for group I, and Si is the standard deviation for group I. So now, how ANOVA works. Crux of the matter. Suppose that instead of an A-B test, we had a comparison of multiple groups, say A, B, C, D, each with numeric data. The statistical procedure that tests for a statistically significant difference among groups is called analysis of variance, ANOVA. ANOVA. So let's look into this ANOVA in depth. So ANOVA measures two sources of variation in the data and compare their relative sizes. So ANOVA, or analysis of variance, is a statistical method used to compare the means of two or more groups. It's an hypothesis test that determines whether there is a statistically significant difference between the means of multiple groups or not. That's it. Pretty simple. So now the basic idea of ANOVA is to partition the total variation in a set of data into two components. The one component is variation between groups. The first component is variation between groups, and the second component is variation within groups. That's it. These are the two components. The basic and then fundamental idea of ANOVA is to partition the total variation. That's why the name says analysis of variance. So partition the total variation in a set of data into two components. One, the variation between the groups, and the variation within the groups. So if the variation between the groups is much larger than the variation within the groups, then it's likely that the means of the groups are different. But before that, let's see what is the variation between the groups. So variation between the groups means for each data value between, I'm talking about the between group 1, group 2, group 3. So for each data value, look at the difference between its group mean and then overall mean. So this is what now you would get it. So x bar I means mean of the group. If you have three groups, mean of group 1 minus mean of the total data set also, plus mean of group 2 minus no summation of difference summation, sorry, I repeat. So variation between groups is calculated as the mean of the total data set is subtracted from the mean of the mean of the individual group, and then result is squared, and then we will do it for the each group and we'll sum it up, and that is called the variation between the groups. That the after summing up, what you get is the variation between the groups. So it's nothing but the in each group mean will be subtract each group mean and then mean of the total data set. That's variation between groups. So for each data value, look at the difference between its group mean and the overall mean. And variation within groups, it's pretty straightforward. For each data value, we look at the difference between the value and the mean of its group. We know that. We know how to calculate the variation in a sample. Now, same thing. Here you will have three groups and we calculate a variance, sorry, not variation, variance for each group. And this is the formula. Xij. So, individual number, so Xi group X1 is group number, J is the number respective to that group. X1 2 means uh, group 1, and then in group 1 the second record. That's what is X1 2. X3 4 means group 3 and the fourth record with respect to that group 3. So here it's pretty straightforward. It's calculating the variance for particular group. So that's it. Once you have the variation or variance, it's calculating the variation between groups is nothing but the variance. So variation between the groups and variation or variance. So once you have the variation between groups and variation within groups, now it's time to calculate the total variation. So total variation you can easily calculate. So once we have these two things, now it's time to calculate F statistic in ANOVA. If you remember in our previous course, intuitive sampling and distribution course, in that course we have calculated F statistic using the chi-squares, using the chi-square. So there we have calculated the chi-square, but there I have told you there are two ways of measuring F statistic. One is ANOVA and second one is chi-square. So there we did the chi-square. Now we are doing ANOVA. So once you are done with both the variation within group and variation between groups, then it's time to calculate the F statistic. So the ANOVA F statistic is the ratio of the between group variation divided by the within group variation, and this is what the formula. So F statistic is equals to between group variation, we call it as MSG, mean square group, and within the group variation mean square elements. Okay, MSG and MSE. So once you have calculated your F statistic, now a large F is evidence against null hypothesis, since it indicates that there is more difference between, if it is large, if F statistic is large, it indicates that there is more difference between groups than within groups. So that is the reason. So we reject null hypothesis because it's clearly saying those are not same. If a statistic is large, that means the between the mean square in group, the mean square in group is larger. So when that is larger, it's clearly telling na they are not same. Each group is not same. They have clearly, there is a difference between each group. So that's what the F statistic will do. And uh, once you know the F statistic, it's time to determine the significance. So how do you do that? Using this, the significance. If the p value, once you know the F statistic, and obviously you can calculate the p value. If the p value is less than alpha, that's 0.05, that's agreed upon significance level, then the null hypothesis is rejected, and it's concluded that there is a statistically significant difference between the means of the groups. If the p-value is greater than alpha, then the null hypothesis is not rejected. Null hypothesis will be confirmed, and it is concluded that there is not enough evidence to suggest a difference between the means of the groups.